Hello, in this tutorial I'm going to show you how to do an express simulation on a single part. Let's go to Tools and Simulation Express. First we have to set the options if you want system of units to be changed to English units. You can select it here, and your results locations, it's better to keep them right next to your parts, and let's show annotations for maximum minimum values in the results plots. So I'll just go OK with this and call next. And we have to go over these steps. First, fixtures. Let's add a fixture, and I am going to select the bottom part of this part, bottom face of this part as a fixture. I can add multiple surfaces like this. For example, I can add multiple surfaces in a single fixture. I can remove them by clicking on them, so I'll just keep the single face as my fixture. Say OK. Next, you can edit the fixtures by right-clicking and saying Edit Definition, and you can add and remove surfaces. Next, I will add a force on these two surfaces, and my force is going to be normal to those surfaces. You can say that the forces are going to be towards selected direction. You have to use a plane like this, which is not created in this case, so I'm not going to use it. Say normal, and units, value, let's say 1000 newtons, and my force is going to be, in this case, 1000 newtons per item, which makes it 2000 newtons in total, but I'll call it total for now. Say OK. Next, I'm going to add a pressure. Likewise, I will select these two internal surfaces, and likewise you can use the reference geometry, and in this case when I select this plane I can give a direction which was not available in force options. I can give a direction. I'm sorry, I want to change these two faces, not those faces. Let's go these two faces. Okay, these two faces are my faces I'm going to apply the pressure, and you can change the directions along that plane for the pressure, or you can call it normal to the plane, which makes it a pull on the surface and a push on the surface, which is nonsense. So I'll just say normal to the selected face, which is the natural option. Again, the units you can change. This is for Newton per meter square, so I will give a large value and say OK and call next. Material, let's select not a steel but soft material like copper. Apply, close. Next, change settings and change the mesh density to something finer, and you can watch the mesh parameters changing. I'll call the mesh parameters to, for example, 1.2 millimeters, and that's the maximum. This is the minimum for the mesh element sizes, and say OK. Mesh has been created, and let's say next, and let's run the simulation. It's going to take a short while I am going to stop. Okay. Now I have this animation which gives me the deflection to the parts. Let's stop the animation and see. Let's say we're done with the deformation and say yes, continue. Or if you do not like the deformation type, you can change your values here anytime and rerun the simulation again. But I'll say yes and continue to watch my results. this is my factor of safety results, which tells me that I have a 2.65 factor of safety on this corner right here. I can change my factor of safety level, let's say 3, and I will see, let me hide these so that my vision is cleaner. You can see a red area here, which is all of this red area is below factor of safety 3. Let me change that to 5 and click again. See that all of these areas are below factor of safety 5. So you can check your part's condition using this factor of safety, which is crucial. Let's see displacements. Here you can see that my part is displaced by 1.2 times 10 to the minus 2 millimeters, which is like 12 microns, and the view here is scaled by this value, 271,000. So it's not realistic, just showing you in which direction it's deflected. You can see the deformation, just the deformation, and this shows you the scale of deformation. And of course we have the stress views for von Mises stresses. In this case you can see the maximum strength, which is way smaller than my yield strength. When you're done, you can go here and say done viewing results, and you can generate a report, and you can generate the eDrawings file where you can use where people can use without having to install Solidworks. I'm not going to do those, but you can create a generate report and hand it in to me. Next, you can optimize your design, say yes and next. In this case, what you do is this: you select the dimension. In this case I will select this dimension and say OK, and say that that dimension is, let me change that dimension between 3 millimeters to maximum 8 millimeters. And while doing that, I will have to give a constraint factor of safety of 2, let's say. And my goal is always my mass is to be minimized. So when I say run, it's going to take a while. While doing that, I will pause it. Now we have a result saying that if I use 5.5 millimeters of diameter, I will get 2.55 factor of safety, and which is one of the options that one of the values it has used. So if you go to 6 millimeters, the factor of safety increases, so it's not going beyond that value. So this is an optimal solution in this case. So if you want to select that, you select it, or if you want to change anything, you can go to edit constraints or edit dimensions, etc. When you're done, say next, and that's it. This was Express Simulation. See you next time.